I am drawing some rudimentary programming in assembly lessons from the Hayden book, Commodore 64 Assembly Language Programming. Now, normally, when I'm teaching a new programming language, I usually like to start with a simple animation and then teach various other bits of code relative to that, such as a for loop or if-then statement and such things. But I kind of feel in this case, you kind of might want to understand a few prerequisites first, Otherwise, you're just blindly copying code over without necessarily understanding what everything does. Some people prefer to work that way. I like to work in baby steps and understand every little bit and how it all goes together. So I'm not going to go too deeply into that. Here we go. Let's see. Here's where I started before. I copied over this code. And to be fair to the author, this was not the first code example. I said, oh, the first code example is erroneous. Well, it is, but he's not actually telling you to type this in the book. He's just kind of saying, well, here's how you do something in BASIC, and look how streamlined and elegant it is to do it in assembly, which is actually not entirely true. This is, as I said, incorrect, and in order to make this do that, it would be probably twice as long. So I don't know where the author's going with that. Um, so here, you know, the book is handy for those of you that enjoy reading, um, in that goes into in-depth explanations of what everything does. So that's all helpful. Here we go. Our first program, 1.1. Let's go ahead and launch that. What is this actually doing? Print. Pretty simple. Just print a letter, which we have already covered. But there's something to be learned here. Repetitions really help you to recognize bits of code from memory and stuff, I think. Okay, so start address 828, we discussed earlier. You're probably better off with 2064 or something like that. But again, I'm just going to go by the book. Starting address in memory 828. Good. LDAIM, which let me tab in. That is the same as LDA immediate mode 0. Okie dokie. And then we'll store it in the whatever's loaded into the accumulator into the first position of screen memory. You should be familiar with by now. Also, use the same value of 0 to define the color. 55296. After a while, I see you start to just memorize these numbers, so that's why I think repetition is useful. Slight variances from one program to the next. Okay, and we don't need to enter the end because that is a command specific to the Hayden Assembler. Let's just go ahead and launch that. And of course, we need to write type sys. You don't need a space, 828. And there is the 0 first character, which is a ampersand. And here he's recycled the same 0 for the color, which happens to be black. Okay, simple enough. Let's move right along here to another. Okay, so see there a little bit of, this is mostly telling you how to use the assembler itself, but here's an explanation of add with carry and such, if you want to get a little deeper into it. Okay, so here's the actual bit of working code. And this is done slightly differently than, let me just minimize this, move it over so I have room to see all of the code and remarks, comments there. Let's do another one. What does this do? This is addition. So I'm going to right click here, add new file, addition, which we've covered addition, haven't we? Yeah, but repetitions are good. 828, memory location. Okay, so here he goes CLD, which clear decimal, which is not explained in the comments. So that's, although it's probably explained thereafter in the book. CLC, clear carry, which I demonstrated is necessary for the math to work correctly. LDAIM means immediate mode number 1. Store that to the first position in screen memory. Also store the same one STA to 55296. See how these arbitrary numbers start to seem familiar after you've seen it several times? Then it all starts to gel, all right? Now LDA, immediate mode 2, yes. Tab, add with carry. Whoops. 1024. Okay. Now this is interesting what he's doing here. I believe in a earlier example, we stored the value in a memory location. That was 900 in that particular instance. But here, this is interesting what he's doing here. He's putting the value into the screen memory location and then drawing from that same spot in memory to draw the second, to do the addition, you see. So we're coming from this screen memory location, doing the addition, and there's the value which he then proceeds to print to the screen, STA 1026. So we know that that's 2 slots over position number 3 in our screen, or we should know by now, STA 55298, colorize the next slot. Okay, and that's it, RTS, return from subroutine. That should do her. Let's see how many errors I've made typing this simple program. Okay, sys 828. There we go. You see? So here he has colorized the first slot using the 1, done an add with carry, and it did not come out to a 2, which we know would have been red. So some result of this came up with the color blue over here, but there you go. We have added 2 numbers together. We got the correct result. Oh, okay, that would be 3. There, color number 3. The result from the addition stored in the color value. You see, I just thought that was an interesting example how instead of writing to a separate slot in memory, he just grabbed the value right back out of the screen memory to do his addition. Okay. There, so there you go. There's another lesson. I will keep them short and